Hey guys, so I have to start off this week with an apology. In my excitement after interviewing Bill and Ava for this week's podcast, I completely forgot to upload the audio only version of last week's podcast. So that was finally uploaded on Thursday instead of Sunday. I value being on time, and the fact that this was 4 days late, five days late, really, just bugs the heck out of me. So I am so sorry about that. This week, I will of course remember to upload not only the video to YouTube but also the audio, so that everybody who just listens to this will will be able to listen to it on time. So my apologies. But with that being said, I am really excited to bring to you guys to share the conversation that I had with Eva Håkansson and Bill Dubé. They are a dynamic duo that they're both mechanical engineers by education. And Eva is actually the current world record holder. She is the fastest electric motorcycle. They built this. They built this motorcycle all on their own. They have a history of building electric motorcycles, both independently, separately, as well as jointly for the last decade or so. I won't give away all the details because obviously that's a lot of the conversation, but it is so exciting to have had the conversation with them. They are really down-to-earth, great people, and I think you guys will love this just as much as I enjoyed having the conversation with them, learning about their current project and what they've got going on. Before we get to the interview, of course, I do want to thank Titan Auto and Tire in Moseley, Virginia for their support for this podcast. Titan is one of the very few independent shops that are qualified to work on hybrids and EVs, and from hybrids to Hummers, they fix everything. I do also want to thank our new Patreon subscriber, Ian L. Last week, I put that at the very end of the episode, where I do like to thank all new subscribers and producers on Patreon at the very beginning. So thank you once again, Ian, and everybody else that is supporting EV Resource on Patreon. We are very grateful that you guys choose not only to share the podcasts in the magazine and listen and read and all of that, but to also put forth your hard-earned dollars in support for what we're doing. So thank you so much. We appreciate that. But without further ado, let me introduce to you guys Eva Håkansson and Bill Dubé. Bill and Eva, thank you very much for being on the EV Resource podcast. It is an absolute pleasure and honor to speak with you both. Thank you very much for your time.
Thank you. It's our pleasure.
Oh, yeah, it's fun.
Our honor.
Absolutely. So you both have quite the history of EV motorcycles. Of course, Eva, you kind of got that from your dad, I understand, and then working originally with a converted motorcycle, the Electric Cat.
Oh, yeah, absolutely. So electric vehicles and motorcycles is totally a genetic disorder on my part.
I did electrothon back in the mid-90s and electric drag racing from then. Yeah, we were in electrics before it was cool.
You took the words out of my mouth.
Yeah, so you both kind of, that's why you met, right? It was, 13 years ago that you met because of your book, Eva, and then kind of got involved. I did some research.
Yeah, that's correct. I wrote the book in Swedish in 2007 about electric and hybrid vehicles, because that was the brand new thing, and people didn't know much about it. So I was asked to write a little popular scientific book. And I had heard about this Kilocycle bike, which was the fastest electric motorcycle in the world and the quickest electric vehicle overall at the time. And I went online and managed to find who was the builder and owner, and sent him an email and said, "Hey, can I use a picture of your motorcycle in my book?"
And the rest is history.
And that was still.
Yeah, as they say. Yeah.
She wrote me a little one-page ask for permission to use a photo, and I sent her back a multi-paged email all about the bike and what we do. There aren't many people who, at the time, who were interested in what we were doing.
Sure. Well, I would even push to argue that there aren't enough people that are interested now, which is a big reason why I would say the three of us are doing what we're doing. You know, we're doing different things, but I think a lot of it has to do with the same reasons to help push awareness and the boundaries of what people believe electric vehicles are capable of. Eva,
Yeah,
yeah, go ahead.
well, our work really predates Tesla. So
Yes.
Tesla has done a lot of the work for us these days. But still, despite, I mean, the showrooms, they actually exist cars in the showrooms you can buy these days. People still don't know much about electric cars.
Hmm.
And most people have never driven one or never ridden in one.
Yeah, yeah,
So
that's very
there's still
true.
work for us to do.
And you
People
guys
don't
have
even think you can buy one. There are, like there are in the there are people who are when they did a survey and asked what percentage, what last year they did a percentage.
It was about 3 years ago, 60% of the US consumers didn't know you could buy electric cars. I think it's quite a bit better now, but still.
one could
Weren't
hope.
even aware.
Yeah.
Yeah.
So, you both are doing things that not just, of course, talking about EVs and being the evangelists for the community that you are, but you guys are going really as far as you can go with that in terms of building your own. You've been doing that for a decade. I do want to have you share.
More than a decade.
Oh, absolutely. I want to have you share a little bit about your first project together that really, Eva, you set the world speed record for an EV motorcycle, the Kilojoule. Let's start with that, the project, kind of how you guys decided that was something you even wanted to do at all.
So about 10 years ago, well, first off, when we met, Bill was drag racing the Kilocycle, and I helped him out with that. But I wanted my own project, and we also realized that drag racing is awesome. I mean, you do 0 to 60 miles per hour, or 0 to 100 kilometers per hour in less than 1 second, and that's impressive. But and people get, wow, that's really cool. But how fast is it? Is always the question you get when you talk to people. Sure. And going fast with a high top speed in a quarter mile is incredibly difficult because you have so little room. You just run out of room before you reach your top speed. So the Kilocycle only did 174 miles per hour, 280 kilometers per hour. And that's impressive, but it doesn't blow people away.
Sure.
So we decided to make electric vehicles cool. They have to be really, really fast. And the way to go fast is in land speed racing, where you have lots of space to get up to speed. So salt racing, for example, at the Bonneville Salt Flats. So we decided about 10 years ago, so why don't we build an insanely fast vehicle? And we were into motorcycles, and motorcycles is also, you get more speed for your money.
Because the power plant, you pay per horsepower, pay dollars per horsepower. And how fast can I go on a limited amount of horsepower? Well, if I only do 2 or 3 wheels, then everything gets smaller and the budget becomes condensed.
And everything shrinks with that. The trailer, the truck, the crew, support equipment, everything shrinks when the vehicle shrinks.
Well, and making it electric as well, I would say, simplifies the process as well, because you're not going to have as many need for replacement parts to bring along with you and all of that either, correct?
Yes and no. You have to realize you can't go to the corner parts store and buy parts for your custom-made electric vehicle.
Or ask a fellow next to you in the pits, can I borrow you whatever?
Can I borrow a contactor? No.
No, but I have 3 sets of clutches if you need one.
Yeah, an extra set of clutches. Yeah, exactly. And so that is you're on your own as far as that goes in racing. But it's, it is.
I would say if you know what you're doing, it certainly is easier to tune an electric powertrain than an internal combustion powertrain.
Yeah, and also in the early days, even now, electric powertrains, because they're not quite so mass-produced, and OEM parts are not, and aftermarket parts are essentially not produced, then the powertrains cost a lot more per horsepower than gasoline ones do, because you need a custom one, and that's and they cost more because you can get the used market for internal combustion is quite large, right? And the used market for and electric is not large.
Not much at all. That's right. So with the kilojoule, you guys had to really piece together, and you had to go and approach other businesses or other companies to really piece together what you wanted to build.
Hmm.
Yeah.
We originally borrowed the drivetrain out of the
Sure.
out of the kilocycle
Yeah, the very
Okay.
first year, we actually just stripped it out
and just borrowed it.
and put it into the
Put it in.
kilojoule.
Okay.
Yeah, it's that we got us going, but that's about it, and managed to get us get interest of other people that we could
Uh-huh.
do this.
We did go on that kilocycle powertrain. We wasn't really suitable for that kind of long duration. It's about a 2-minute run in land speed racing instead of a 7-second run.
Uh-huh.
And also very hostile and actually inhaled salt dust and arced over and blew up. But we did go 138 miles per hour, 200 and a bit kilometers per hour, which was a
on a
world record,
kilocycle drivetrain.
which was our
Right.
very first world record in land speed racing, which actually happened on my 30th birthday.
Oh, well, that's a good birthday present.
It was a pretty good birthday
Yeah,
present.
we used to go every year on your birthday.
Yeah. So the Bonneville all motorcycle event is always on my birthday.
Hey, that couldn't have worked out better, I guess, right?
Well,
So-
you know, they do that for her. You know.
As they should. So your current record is 270 miles per hour, is that right?
So 270.224 is our registered top speed.
Okay,
Our current record,
Which requires a two-way pass.
correct.
official,
Down and back,
world
right? Yeah.
record, that has jumped through all the hoops and all the technicalities is 248
Okay.
miles per hour, or just a touch over 400 kilometers per hour.
And
That's the
that-
official record.
And that is the record for an EV motorcycle right now.
That is correct. That is the number 2 in the world is about 50 miles per hour behind us.
Hey, okay. So you guys are just, what do you think you can attribute to that type of lead? I mean, that is pretty massive that you're so far ahead of anybody else in that
Being
space.
Being first.
Being first.
Okay.
Being first. Yeah.
So-
Also, I might add something that really passed people by and nobody really noticed is that we, for 2 years or a little more than 2 years, we held the overall sidecar motorcycle record by a large margin.
And that was the first time since 1899 that an electric vehicle held an overall record in its vehicle class. But no one noticed.
No one noticed, you know. You know.
Well,
It's
yeah,
like-
you don't see too many 3-wheelers out there on the salt flats. I would
Yeah.
That's
imagine.
an obscure record.
Yeah.
But it got the notice of the sidecar people.
Okay.
Yeah.
Like, what? What?
Hey, wait
You
a
know?
minute.
And they cleaned up their act.
and they cleaned up. They actually.
I think they kind of.
we think they kind of copied our. We did a few tricks with aerodynamics that we think they copied. We're sure they copied actually, and then they just blew us out of the water. But it's our turn next. Yeah.
Yeah.
Records are only borrowed; they aren't owned.
There you go.
Yeah.
That I like the way you put that. And you guys actually have your sights set on the overall motorcycle record, not whether it's gas powered or electric. Is that right?
That's correct. So just to give you just a few stats, so the kilojoule, our previous motorcycle, is the world's 4th fastest electric vehicle. There are 3 cars that are faster.
Okay.
It is of all motorcycle runs ever made, official record, unofficial records, I and kilojoule are number 19 in the world. So there are 18 motorcycles and riders that have been faster than we are. But we have the eyes set for the overall motorcycle record, which is currently at 376 miles per hour or 605 kilometers per hour.
Mm-hmm.
And the math says that it should be doable.
Yeah, with the new bike.
With the new bike.
Yes.
So
We
you
have
can
the old
see,
bike. Yeah.
move a bit.
Okay. Yeah.
Yeah. So I do want to dive into the bikes themselves. Of course, you guys are pushing about 1,000 horsepower right there. Is that
That's correct.
and that's is that using one or two motors?
Depends a little bit on how you look at
How
it.
you define motor.
How you define
Okay.
the motor. So what the Green Envy has two motors from Avid, which is a British manufacturer. And inside each motor, there are actually two electric motors, like a two-cylinder engine. But it's a two-cylinder electric motor.
Okay.
So there are two rotors, 6 phase wires coming into each motor. So there are two of those setups
On a common shaft.
on the same shaft. So electrically, it actually has 4 electric motors.
Okay.
And 4 inverters from Cascadia Motion.
Wow. Okay. So that's impressive. I mean, that's really impressive.
That is run with 2 battery packs from A123 system.
Wow.
It's a bit of an odd setup, but what we did, first off, it works great. And what we did, we took the kilojoule setup, which had one of these Avid motors and 2 Cascadia motion controllers and 1 A123 battery, and we just doubled it. Because it was
a winning system.
It was a winning system. We knew it would work, and we thought, why do something new?
You know,
we have great partners. Everything works. Let's just double it.
They could have done something different, and they were happy to do something different. But we said, let's just do more of the same this time around, this iteration.
So in that aspect, you could say you didn't reinvent the wheel, but I think you know where I'm going with this. In another aspect, you basically did reinvent the wheel, and I want to share that with everybody because it is easily one of the, I mean, people that know you probably aren't surprised. I mean, you both have degrees in mechanical engineering. You aren't afraid of thinking outside the traditional box. That wheel, for people that aren't familiar with that, start at the beginning, kind of where you came up with the need for that, the reason that you had to redesign what you were working with, and then why that's working so well.
Where are the parts?
Let me get some. We can show this one.
Yeah.
Okay.
Yeah. Just a sec. There we are. That's perfect. Perfect.
Well, the beginning
cool.
is that tires seem simple. You need tires for your car. You go to the store. You buy tires. Well, in land speed racing, it isn't that simple. There are basically 2 manufacturers that make tires for 300 miles per hour and above. And they come in a handful of sizes. And they're basically large, giant, and humongous.
Which just doesn't work.
Which doesn't work that well for a motorcycle. So when you build a motorcycle streamliner, the kilojoule and the Green Envy are streamliners. They kind of look like cars, but they have 2 or 3 wheels. Like a rocket. But they're relatively small wheels. When you build a vehicle like that, the first thing you have to pick are the tires.
Because you have to build a vehicle around the available tires. Because you can't make a tire yourself. And you have to go with the available tires.
Yeah. So that's your first problem, is that the very little selection for small vehicles. Secondly, blown out tires, when you're driving on a highway, that's kind of an inconvenience. You pull over and you pull a tow truck. If you're going 400 miles per hour, you blow out a tire. In best case, your blown up tire just takes out a chunk of your vehicle and you have lots of repairs to do. But more common than not is we'll send you airborne and you don't know what's going to happen.
That's the end of the vehicle.
Yeah.
And hopefully you'll be okay.
Hopefully it's not the end of you.
Yeah.
So you have 2 problems, finding tires and tires blowing out and being a big safety hazard. So we thought, there must be a better way of doing this.
We were thinking, we want to build something different, like a different width or a different size, and we can't. And this, we felt constrained.
Yeah.
And we also knew that we got to go faster than the rating on the tires. There is no guarantee on the tires at all, but they don't even want to talk to you if you're going over 350 miles an hour. You're
on your own.
You want to buy it, give us cash.
You actually have to sign a 7-page liability waiver to buy tires.
Wow.
Yeah.
And I am the only one allowed to drive the vehicle. And if someone else wants to drive it, they have to sign the same waiver and send it to the tire manufacturer.
Yeah, these are not gonna, these we don't even want to hear about it.
Yeah.
Talk to the hand.
So we looked at the jet cars. So the big thrust-powered jet cars, the fastest one, the Thrust SSC, which is actually supersonic.
Yes.
They run on solid metal wheels. So it almost looks like a railway wheel.
Because they don't need traction.
They don't need traction. Exactly.
All you have to do is kind of steer, and they steer aerodynamically anyway.
Yeah.
Wow.
So, but we need traction because what we do are called wheel-driven vehicles. So they transmit power through the wheels to the ground. So we need a rubber tread to grip the ground. And we thought, can we design a wheel that can run flat, but still gives us this grip? So we've been dwelling on the idea for a few years of thinking, well, how can we add rubber to a solid wheel and not just have it fly off? Because if you just put rubber on the outside of a wheel at 400 miles per hour, you have 10,000 Gs pulling on this rubber.
10,000
Gs.
Something that weighs a gram.
Yes.
Weighs
10
kilograms.
Yeah.
Yeah.
So we thought, okay, well, can we mechanically fasten this rubber to the wheels? And then the idea came, well, maybe we can take this jet car wheel design, drill holes through it, and kind of have rubber grow through.
Like a stubble.
Stubble. And that's how
how you came up with this
idea came up. Here's a little test section I can show.
A little model.
Oh, look at that.
What this is a 3D printed test section, but it has a cast rubber mat of industrial polyurethane rubber that has these studs on it. And then it sticks through holes in the rim. And then it's held into place with a retention band on the back.
That's for low speeds.
So the weight of the vehicle won't just push it out.
Right.
And it falls out. And a finished wheel looks like this.
Oh, that is so beautiful.
It looks like something that NASA would put on their Mars rover. But probably if it was NASA, it would put down a secret message in Morse code.
So then, of course, at high speeds, where, the retention band is not needed, the force is actually pushing that rubber against the metal that you have, basically holding it from flying apart. That's
correct.
Yeah, they grow a bit.
They grow about 1/8 of an inch or 3 millimeters at full speed. If that's what the calculation says they will.
Because they're being pulled on by centrifugal force.
Yep.
And then they're compressed about the same amount when they hit the ground. So we have, we think it's a viable idea.
Seems to work so far.
We have run it at 236 miles per hour last year in Australia without any problems.
None.
The only bad thing is that it demands very much of your.
Doesn't provide much cushion.
No, so because this is a solid wheel.
Sure.
You have to have really good suspension on your vehicle, which we didn't have on the kilojoule.
No, it was very primitive on the kilojoule. It was adequate for rubber tires, but was inadequate, or it was marginal for these tires.
So luckily, being Swedish, I managed to convince the
Swedish,
the suspension manufacturer Öhlins to design a custom suspension for the Green Envy.
Oh, cool.
So we have. It's so pretty. You have to show it.
Yeah. Oh, I'd love to see it.
Just tilt the camera. There it is. So that's the front end.
Oh, wow. Okay. Yeah, look at that.
So hopefully that will be good enough to run these solid wheels.
Sure.
And if it is, then we have basically solved all tire problems, hopefully.
And we have the same on the sidecar and on the rear wheel.
Mm-hmm. Yeah, because naturally you'd want the characteristics of the suspension to behave the same way at all of the corners of the vehicle.
All 3 corners.
Or 3.
All 3 corners, yes. So with the Green Envy, That's something you guys haven't had a chance to run that yet, have you?
No, so
No.
we were the planned debut.
Close.
The planned debut was for Australia this year, and it was in Australia. We were in Australia. We were ready, and then the pandemic hit, and the world was just
slowly closed in on us, and they just pinched us off before we could go. It pinched off the event. It was just like if we had been there a week, if the whole thing had happened a week earlier,
It would have
or if
happened.
the pandemic had happened a week later, it would have occurred. But it was just like days away from happening, and they just said, "Nope, the tide has come in. We
Sure.
cannot do the event." It was medical personnel was the
final straw.
final straw, because all the medical personnel had been banned from at that point were banned from all sports events and drawn back in. They said, "Nope, you're needed back at in the hospitals."
And the medical staff are all volunteers. So they go on vacation.
All
and
vacations
go
were
work the
canceled.
race.
Yeah,
And they
Yeah.
all their vacations were withdrawn.
Yep.
So that was the final straw. But it is what it is. It gives us another year to get ready, I
Yeah.
guess.
yeah, you got to roll with the punches.
Absolutely. So over the course of the next year, I mean, that gives you a fairly a decent amount of time to really look at what you're doing and make small little improvements as you go along the way. I understand you
We'd
have,
be doing this anyway.
yeah, of course.
Doesn't matter.
You guys have a 3D printer where you're planning on printing a lot of parts.
We have 5 3D printers in use, and we do print a lot of. We actually print a lot of cool parts. Hang on to that.
Yep. Well, we printed the model for this. Hand me
Uh-huh.
the model. Oh, yeah. The model for this is all 3D printed. This is all 3D printed. This this is all 3D printed. And we print all kinds of clothes. She's going in the other room to get
Sure.
something. But we print all sorts of things for the. You end up printing things that you would never consider printing before. Like you're about to do something and you need a little template, a little drill template, and you think, well, I'll carve this out of metal or something, and you think,
Oh, wait a minute.
I'll 3D print it. Right? It's like, yeah, that's easy. And the next morning, it's next hour, it's in your hand, and it's perfect. Yeah.
Right.
I was telling about the drill template.
Well, I have a drill template in my hand. So this looks kind of goofy, but this is a little template just to install caster wheels on a cart in the right place.
Uh-huh.
And it saves
Okay.
a huge amount of time.
Yeah, because you think, oh, I'm going to make this out of metal to make a little, or paper. And you realize, no.
So this is kind of unsexy part, but you can also make sexy parts. Like this is an Anderson connector cover.
Oh.
Connect
okay.
for like on a forklift, but we
Yeah.
use them on
The electrical connection?
large electrical connections.
And it's rubber.
Okay. Strong enough. And it's
Oh,
surely
this is
protect everything.
really
Yeah.
strong.
And you can make them in whatever color you want.
That is really cool. So I understand that you are wanting to work with recycled plastic.
Yes.
Boy, you have done your research.
Wow, that's you certainly have. Yes. Before I just talk about that, I just want to show you. I picked up another thing.
Yes.
In case someone didn't understand how these wheel nubbies work, they're actually mats like this. So this is the key wheel rubber inserts. This is the one for the sidecar wheel. It only has 1 row. The rear has 4 rows and front has 3 rows. And then those retention bands screw right through the rubber.
And then that's held into the rim, if you can imagine.
Yes.
And these poke through.
Yeah.
Like this.
Yep. You put it in like that, and then you put the band on, screw it right through. And
that is brilliant.
And the way we made these, because we're always short on money, you have to be long and clever.
Yeah.
So I 3D printed a plug. So this is the positive tread pattern.
Oh.
Then I poured in a 2-component silicone to make myself a mold.
Yep.
And then these pieces were cast into the mold.
Sure. Wow.
You can see that this.
That's the
wrong mold, but you can see how this would fit in,
Mm-hmm.
and you'd pour this is the same height.
Yes.
You can see is it so these come out of this, and this is flexible. But this is You also, the tread pattern, you can decide what tread pattern you want. It's like
Smiley faces, Hello Kitty,
Yeah.
hearts, whatever you feel like.
Whatever imprint you want to leave on the sand.
Exactly. Yeah. Whatever mark you want to leave
on the
sand.
salt.
yeah.
Yeah.
Well, that's great. So you guys really embody the do-it-yourself
Oh, yeah.
world.
Oh, yeah.
I mean,
Oh,
yeah,
yeah.
yeah.
if you
Yeah.
want something, you're creating it, you're building it. You're not waiting for somebody to come up with it to say, okay, well now they have made that, so we're going to use it. You're charging
We
full
try
speed
our
ahead.
best. We try our best with existing technology, and if it doesn't suit us, then okay, I guess we're going to have to make it ourselves.
Or simply can't afford it.
Can't afford it. We can't
There are
afford
lots
it.
of things we can't
You
afford.
can't afford, and we just build it ourselves. Like our data acquisition system for the the data logger and the data system for the bike. There are thousands and thousands of dollars. We even had sponsorship from a company to get it, and we did, but this is way too expensive. This parts are way too expensive, and it wasn't transparent to us how to work it. So we just built our own, rolled our own, and it was inexpensive to do.
So you asked about recycled plastics.
Yeah.
So actually, our latest project, and this started during lockdown. So when the pandemic hit here and New Zealand went into 6 weeks of total lockdown,
we could unplug and go in the other room and look. We could.
Good.
Do you want to do that? We have
Hey.
we have a 3D print.
Sure.
All right.
Yeah, let's do it.
Give me the tour. Let's see it.
Okay.
So during lockdown and canceled racing and everything, we figured out, we need to do something. What are we going to do now when we can't race? So we thought, we do a lot of 3D printing. We don't like that we are really contributing to the plastics problem.
Mm-hmm.
And we thought, maybe we can actually make our own filament. We had to work on something that we could do at home because we weren't allowed to go to our workshop. So our workshop is 10-minute drive from home. And lockdown rules didn't allow you to leave your house. So we decided, okay, we can build design a extrusion line at home. So we did. And that was, of course, several months ago, but we are very, very close to the point where we can actually start melting some plastics.
So I can't see his, maybe make ours a little, we can
Okay.
make ours big
Wow.
so you can see.
Yeah. Oh, that is so
I can-
cool.
So this will be a little bit of a amateur video here. So what you see so this is an open source filament extruder system.
Go ahead and give it a tour, point to different parts.
Originally developed by Michigan Tech University, and we are working on their design. So what we have here on the side is the auger motor. So that drives an auger, which is actually just a giant drill bit inside a tube that's heated. You put in your plastic pellets or flakes into the hopper, goes in, melts,
makes a noodle,
comes out, and then
it's cooled
these
off.
are fans that cool it off. And then up a little bit. These two rollers actually pull out the filament, so the way you get the correct size is
faster and slower. You pull.
Sure.
You pull slow, it becomes big. You pull fast, it becomes skinny. Then there's a little bit of a filament size sensor, optically measures the size of the filament and runs a feedback loop to pull slower or faster. And then it winds it up at a spool over here. So in theory, this is very simple. In reality,
in theory. Oh, that is spectacular. And I mean, really, something like that speaks so much to who you are as people and your belief about the mission of what you're doing, really. It's very inspiring, Eva, that you guys aren't just simply, and I say that with some sarcasm, simply going out there to destroy records and build an electric vehicle that is by far I mean, there is no competition for you. But then you additionally want to go out there and say, you know, we want to be mindful of our impact to the environment, and you are incorporating that aspect into it as well. And that's, and you can, I mean, you guys really, you are such a special and dynamic team. I really, honestly, I want to go back and answer my own question, why everybody else is so far behind you. And I think, at least from my perspective, the answer to that is because they're not you. I don't know anybody. And
we do make a good team.
Yes, we do.
Yeah.
I mean, what you guys have done so far, and certainly I am going to be following along very much. And I have a lot of excitement for you to see, you know, the overall record. I mean, Rocky Robinson needs to know what's coming his way, because I expect 400 miles an hour out of this, and I know you do as well.
Actually, Mike Akatif, we've heard rumors that he's investigating an electric drivetrain for his motorcycle.
You know, and
heard, you know, more than rumors. He hasn't asked us. Hasn't talked to us, but it's, there's been. Well, no, he would actually. I'm surprised he hasn't.
Oh, I don't know.
Yeah.
Will we help him? I don't know. That's a tough question.
I don't know. He hasn't asked us.
We're always happy to help people,
happy to help.
But when people get too close to our records, you know.
It's like, hold on.
Hey, well, maybe we won't help you so much.
It's like, help you be second place.
Yeah.
Oh, happy to do that.
No, it's actually an interesting question, because we don't really. It hasn't happened yet. We're always happy to help people, but I don't know. There may come a point when we're not happy to tell all of our secrets.
Well, it's also people in general, people who aren't actually racing and doing, don't really already own one.
Yes.
Not even aware of the nuances that are required, that are necessary to do it.
Yeah, people always ask, "Oh, can I take photos?" And yeah, take as many photos as you want.
Not going to do you any good.
Yeah. Knowing what you're looking at and building it well are completely different things. You know, you have to have the skills and certainly the experience, and you guys have the advantage of learning from so much of what you've been doing. I mean, with Kilojoule, I mean, I know you guys learned a lot about what to do and a lot about what not to do, and then certainly what to do better.
What not to do. Yeah. Good judgment comes from experience, and experience comes from past bad judgment. Yeah.
Well, I'm running up against time here, but you guys have certainly come a long way, and I mean, as soon as I found out that this is a project that existed, that you guys existed, I was very much interested, and I absolutely want to thank you guys for taking all this time. I honestly, I wish I had more time. I really do, because
we all do.
honestly, I could probably go for another hour, but I won't do that to you. But I want to thank you so much for sharing a little bit. I mean, really, just I feel like we scratched the surface about what you're working with. For everybody that's watching either what will be the YouTube video or listening to the audio only on the podcast, how can they best follow along with your journey and show support? And I know there's potentially a way that people can get involved and help you out.
Yes. So following along, the best platform is Facebook. Yeah, we are old-fashioned, but we like Facebook. We think it's the nicest social media community. So Facebook.com/Eva Håkansson Racing. Good luck spelling that, but it's easy.
I'll spell it out on the screen so people will have that.
so Eva Håkansson Racing. If you insist on doing Instagram, Eva_Håkansson, but it's not as good updated. If you want to read more about the project, my website, greenenvyracing.com. And if you want to support the project, unless you're kind of local and provide some hands-on, but if you have, of course, if you have components or parts or things you think we can use, we'd love to use parts. But most importantly, you can get your name on the bike.
And we're cheap date.
We are cheap dates, starting at $50. You get your name on the Green Envy. And you can go either to greenenvyracing.com or greenenvyracing.store, and you will get directly to your options.
Also, I should add, you can take CAD lessons on the, which is CAD is the key to the whole world of 3D printing.
Oh, sure.
So actually the key to our success, to a big extent, particularly building the Green Envy, we built the Green Envy in record speed. From the day the first frame tubes were laser cut to the day it was loaded into the container and shipped off to Australia, it was 6 months and 22 days.
I don't think anyone has ever done that.
And that is thanks to CAD. Everything was designed in CAD. So we had parts made in different places and they all fit together in the end.
Like IKEA.
Like IKEA furniture.
Yes.
So if you go to my website, cadenvy.com, so CADenvy.com, I have free online classes in CAD because that's what I used to teach.
Well, that's one that I didn't know about. So apparently my research only took me so far.
Well, it's excellent.
But
it's actually a little bit, it's not a very well marketed because it's still a work in progress.
Okay. Well, I for one, will definitely take a look at that. You know, I didn't even...
free CAD software.
Free CAD software.
These days.
Cool.
It's
for beginner stuff, because there is no beginner. There really, that's what we saw a big vacuum in the market. There really is, or whatever out there. You can't get started.
Sure.
In a CAD because there's no good beginner courses, and we thought, no, people need to get a start, and this is a free beginner course on CAD, and it'll get you kind of launched out of the nest, pushed out of the nest.
That is great. Well, I will definitely share that as well. I think we are at the cusp, honestly, of a whole new world when it comes to really building our own vehicles. I mean, there's always been certain people that want to build their own stuff. When it comes to cars, tinker with it, take it apart, put it back together in a better way. You guys have certainly exemplified the extreme of that. And that is, it's very inspiring. It's very impressive. And I certainly hope that anybody that might watch this, even if it's a year from now, that is starting their own journey can certainly take what you have to teach and make it that next little step for them.
Hands-on is really what we also try to promote.
Yeah,
sure.
We really want to get people to build more of their own stuff.
Well,
that you really learn by building, and that's a big part of it's often missed in a formal education is building something. It really is part of an education in itself.
Absolutely. Well, thank you very much. I do have to call it, but I really appreciate both of you for taking the time. This has been very special, and I've got no other words other than thank you. So at that, I will say goodbye. Thanks, guys. Have a great day.
Bye.
All right, so we will cut it at that for this week. If you guys are interested in listening to or watching any of the previous podcasts, you can watch them all on the YouTube channel. That's you just go to YouTube and search for EV Resource. Audio only is available on all of the major podcast platforms, and especially Apple Podcasts. If you guys could leave a review, good, bad, or otherwise, honestly, I do mean that. Any interaction with the podcast will help promote the podcast and kind of push it up in the rankings so that more and more people can see and listen, more importantly, listen to what I'm trying to bring in terms of the latest EV news, information, interviews like this, and then ultimately answers to questions that people have about electric vehicles. So this is really, I want to try to bring content for you guys that is for the EV enthusiasts, people that like myself are in the deep end when it comes to EVs, but also the people that are kind of EV newbies, the novice that don't know a lot about electric vehicles that want to learn more. This is for them as well. So share it with your friends, your family, people that you know that might just want to learn a little bit more about electric vehicles. come say hi on social media. The conversation is always there, especially Facebook, but we're on Twitter and Instagram and LinkedIn as well. And if you do want to support the podcast, as I mentioned at the top of the show, we do have some supporters on Patreon. That's patreon.com. For the price of maybe a Subway sandwich, they used to be $5, but I think they're more than that now. Or less, you can be a subscriber to the magazine and get full access to the EV Resource magazine for just $1 a month. And that's a great deal, honestly. But it's completely voluntary. You don't have to. It's just something that, of course, I appreciate, and any support that you can throw our way would be greatly appreciated. But that is it for this week. Next week, we are going to return to the regular programming when it comes to the latest EV news. I felt horrible this week, and I might even do an additional show because there's been so much great EV news going on. But if I don't have the time for it this week, certainly next week we will get back to it. So until then, stay safe, everybody. We'll catch you next time.